Okay, so today we're going to talk about graph of quadratic equations, and we're going to talk about something called discriminant in a minute. But before I do this, like I said, let's review a little bit, okay? Because this will be very similar, okay? If I have an equation, so this is, of course, not a quadratic equation. This is a linear equation. You guys remember? So let's say I gave you a linear equation that looks something like this: y equals to 2x plus 1. And if I ask you to find the x-intercept, we know what the y-intercept is, don't we? Y-intercept is, everybody should know, it's 1, isn't it? Yeah, because remember, y equals mx plus b. That b is that y-intercept. We want to find the x-intercept. Who remembers? First of all, what's an x-intercept? Yeah. Yeah, where the line goes through the x-axis, right? And it says find the x-intercept. John, do you remember how to find the x-intercept? You plug in y equals to 0. Do you guys remember why we plug in y equals to 0 to find the x-intercept? Because that's the key for learning today's lesson. Why do we plug in y equals to 0? Yes, sir. Yeah, if the line hits the y-axis, right? I mean x-axis, the y-coordinate of that point must be 0, right? Where the line crosses the x-axis, right? That point must have the y equals 0. Otherwise, is it possible for it to be on the x-axis? No, so y must be 0. Remember, it doesn't have any height. So when you plug in y equals 0, we can figure out which x makes this equation true. So that x is your x-intercept. So we basically find this, don't we? We plug in y equals to 0. Okay. So we call this equation, after all, isn't this an equation also? We call this a related equation. You can see why it's related. It's the same equation, except we plug in y for 0, right? We had y here, now we plug in y equals 0. Go ahead, everybody, go ahead and find it. I'll give you time. It's pretty straightforward. Okay, so did you all subtract both sides by 1? Yeah? Mm-hmm. And when you do that, did you all get negative 1 over 2? So there's your x-intercept. Now, let's verify. We could actually graph it right here. It's going to, you know how to graph line using slope-intercept form. You start at 1, go up to the right one, and then when it hits the x-axis, we know what that exact point is. It's going to be negative half comma 0. Would you not agree? Yes? Yeah. So that's how you find the x-intercept. Okay. Any questions so far? So we had an equation where, how many variables do we have here? Y equals 2x plus 1. How many variables did you have? 2, x and y. Now, all of a sudden, the y, we plug in 0 in there, and to find the x-intercept, right? Does that make sense? Very good. Any questions so far? Because if you understand this, then you will understand the rest of the lesson. Okay? Are we good? All right, good. Before I move on, there's another name for x-intercept. Anybody know another name for x-intercept? Somebody said something? No? Yeah. A? Yeah, we use letter B for the y-intercept. We use letter A for the x-intercept. But what I'm looking for is, think about this x-axis as like a ground. And you have, what do you think?
Coordinate?
No? That's the y coordinate of the.
Oh, it's the one.
Yeah, remember? Anyway, it starts with R. Anybody? No. So think about this as the ground, and like this is like a tree or something, some plant. Yeah.
Oh,
Root. Yeah, very good. So sometimes you may hear people call x-intercept as root. Okay. We normally talk about root as the one on the ground, right in the ground. Okay, so think about that's where the root and the plant and I don't know. So that's called root. Okay. Are we okay with that? So that's just on your homework tonight. They're going to refer to the x-intercept as root. Is that okay? All right. So just I want you to know. So let's now move on to the next. Let's see whether we could kind of transition from this to now quadratic equations. So do we know with two variables? Let me hold on to this for a second. Now, if you have an equation with two variables, this equation is called a quadratic equation. What, just like y equals mx plus b, which form have you learned about the quadratic equation? What's the standard form of a quadratic equation? In other words, remember we talked about this, a standard form of a quadratic equation? Do you remember? Yeah, what is it? Equals 0. Is it equals 0 really? When we talk about, instead of equals 0, it's really equals to y. Do you guys remember this? F of x. Remember we're talking about parabola. What graph does it give you when you graph? I already said it. When you graph y equals to 2x squared plus bx plus c, what graph do you get? Yeah, parabola. Remember when you graph a linear equation, you get a line. When you graph this equation, remember from last chapter, we got parabola, So when you plug in, how many points did we use to graph this? 5. What was the most important point that you had to plug in? You have to figure out the vertex, right? Remember we found the vertex and we found, using table, we found 2 other values to the left of it, 2 other values to the right of it. Do you guys remember this? And we were able to graph it, and every time we graphed this, it was a parabola. You guys remember that? All right. So just like linear equation, when you graph y equals mx plus b, you get a line. When you graph y equals to ax squared plus bx plus c, you get a parabola. You guys remember that? Now, so here I get some parabola, right? So it's not a particular parabola, I just drew someone, okay? And ABC could be anything. Now, what did we learn last time in this class? We learned something called quadratic formula, right? Formula. What equation does quadratic formula solve? Do you guys remember? We sang the song, x equals negative, right? What's that solution of? Which equation? Right, what's the equation that we solve when we solve? Well, I know the answer. We could all sing it. You know what the answer is, right? But what equation do we solve? Raise your hand. Jay, which equation do we solve and got that, answer x equals negative b? That's not an equation. If you just say ax squared plus bx plus c, that's just an expression. We solved an equation. You guys remember what equation we solved? Robert?
Ax squared plus bx plus c
equals 0. Equals to 0 is correct. Do you guys remember that? Yes, do you guys remember? Didn't we solve that? Remember when we were solving the quadratic equation, it was equal to 0. And we divided both sides by a, right? We moved the c over a on the other side and then figure out what to, add both sides by, right? It was b over 2a squared. And remember? And then we factored that out, right? Because it was a perfect square trinomial, square root both sides. And we got the answer, right? Now, I wrote down they're related. Anybody see why they're related? Y equals to, this one right here, y equals to 2x squared plus bx plus c. Why is that it related to 0 equals to ax squared plus bx plus c? Yeah, one person? 2? Look at the example we just did here. Remember I said review? That should give you some. I'm going to give you some chance to, okay, a lot of you, why don't you talk to your group and see if they agree with what you think. Go ahead, I'll give you some time. Why do you think they're related? Look at the previous example that I just did. So, as you were discussing about this problem, not what you did over the weekend. Right. Sure. Okay. So, yeah, that's good. That's at least better than. Anyway, so something should have kind of. Who thinks they know why they're related? And what is it that we're looking for here? We sort of solved this equation last time without really understanding really graphically what it really means, what the solution meant. 2 people? 3? 4? 5? 6? Allie, what do you think?
So it's related because you substituted y in
Yes, I did. Very good.
You're solving for the x-intercept.
That's exactly right. When we solve, Jisoo, that x equals negative b. You know, what's that solution? What is that? That's your x-intercept. Isn't that cool?
Yeah.
So everything kind of works together. See these points right here? I made it with red dot. Right? Guess what those points are? Anybody know what they are? If they're the dimples? No. If you, I guess, okay. Yeah, we should call them dimples instead of roots, right? So these are roots, in other words, x-intercept, and we now know the exact order pairs for these. We now know the exact order. Go ahead and think about what those order pairs are with your group. Give me the exact order pairs for this parabola y equals to ax plus b, ax squared plus bx plus c. This is a generic parabola, right? This represents every parabola you could think of. Isn't that right? Because you could plug in a, b, c as any numbers you want. Well, of course, a can be 0. Right, doesn't it?
Yes.
Now, we know the x-intercept, the exact x-intercept, the order pairs for these, every sort of parabola you could think of. Go ahead. What would the actual order pair be? What is the order pair for this one? What is the order pair for this one? Go ahead. I'll give you time. See if you could think of this. Okay. By the way, what were our solution for this? Do I need to remind you of what the solution for negative b plus or So we get how many numbers does that represent, by the way? Because you had plus or minus 2. Because you had the one with minus, you had the one with plus, right? You guys remember that? There's one under it. What do you mean? Yo, it was plus or minus, so it really represents 2 numbers, right? So what are the actual order pairs for these roots or the x-intercept? Go ahead, I'll give you time with your group. Think about it. Give me the actual order pairs, okay, of these x. Who thinks they know the actual order pairs for these x-intercepts for this parabola? Y equals to ax squared plus bx plus ax squared plus bx plus c. For this general form for parabola, what is the actual order pair? One person knows. Really? 2? Okay, a little better. 3? 4? Logan, what did you guys come up with?
Negative b plus the square root of b squared minus 4ac over 2a comma 0.
Comma 0 is one of them. The other is?
Negative b minus square root of b squared minus 4ac over 2a comma 0.
Exactly. There you are, guys. When didn't we just plug in y equals 0, just like the x-intercept of a line? Doesn't that give you the roots or the x-intercept? So you know the y coordinate must be 0. Correct? Question.
How come not both of them are plus and minus? Oh wait.
Because when you write plus or minus, it represents 2 numbers.
I just wrote plus and
Right?
minus instead of
Think about it. The quadratic formula gives you 2 numbers, doesn't it? Because you have to separate them. A number can be, if you have plus or minus within this, it means it represents 2 numbers. Yeah, question.
What if they don't have x-intercept?
Say it again.
What if they don't have
I like that question.
They don't have what?
He said, what if the parabolas do not have any x-intercept? We know some lines that don't have any x-intercept. Which lines are these? These are lines that are, yeah? Horizontal lines. Slope equals to 0. So some horizontal lines will actually, as long as horizontal line is not on the y-axis, x-axis, right? Most of them, right? So every horizontal line except the one actually on the x-axis do not have any x-intercept. So do you think all parabolas must have roots? No. Some parabolas won't. When would it not have any roots? Yeah.
When the vertex is above the x-axis.
You gotta be good. If the parabola opens upward and vertex happens to be above the x-axis, yeah, sometimes you won't get any roots. That's okay. When will it not have any roots? There's another case when it won't have any roots. John?
When it's facing downward and it's below them.
That's right. When the parabola is opening down, it opens downward, right, or sad face, right, and the vertex is below the x-axis, then you won't have any roots. That's fine. But for all the other times, you could actually find the roots now. Does that make sense? Yes. Actually, there are times where it would have only one root. Anybody? Can somebody think of when it would have only one root? Because when it has one, it could either have two roots, no roots, right? We just talked about it, or just one. It's possible to have just one root. Yes, sir. Yeah, when the vertex is on the x-axis, either upward or downward, doesn't matter, right? If the vertex is on the x-axis, then that vertex is your x-intercept. Does this make sense? Yes? Are you guys convinced that the order pair for these x-intercepts are, the quadratic formula that we found, basically, comma 0? Are you guys convinced? Ask your group members, see if they understand. Go ahead. See if that's, now think about this, okay? Go ahead. And if you have any question, ask me or ask your group members. Does this make sense? This should make sense to you, because if it doesn't, then we need to work on it, okay? Think about this. Does this make sense? Okay, so I have, okay, may I have your attention? Yes, we said this last week. We have a quiz on Wednesday. Okay, anyway. So I have drawn the pictures for you with two solutions. Let's see if this is what we were talking about before. Remember we said, oh, you can have two solutions. When a is greater than 0, you're going to have smiley face. When the vertex is what? Where? Below the x-axis, right? Do you see my vertex right here? Oops. Okay. My vertex is below the x-axis, correct? Or you could have a less than 0, meaning it's going to open downward, and then you have vertex above, right? Right up there. Are we okay with that? When do we get no solution? We just talked about it. When a is greater than 0, the vertex is above the, where? X-axis. Where if the parabola opens downward, then vertex is what? Below the x-axis. And we get one solution. There are two cases when the vertex is on the x-axis. See my vertex? So on your homework, actually, it's going to ask you where the vertex is in terms of why we get two solutions. Does that make sense, guys? You see my vertex? Let me do it with blue. Right here. Right? So when the vertex, depending on A being negative or positive, and depends on where the vertex is above or below the x-axis, you would either have two solutions, no solution, or one solution. Does that make sense?
Yes.
So you might want to draw this picture. And some of you ask, Ali, what did you ask? You asked.
What happened? How do you figure out like the equation and the points when there's no solution?
Right. We're actually going to talk about that in a minute. So that's a really good question. Ali is asking, is there a way to know? Wouldn't it be great before drawing this thing, whether or not you have one solution, no solution, or two solutions, two roots? There's actually a way to figure this out. So as you draw the picture, think about when that might be. What makes that because after all, doesn't the quadratic equation give you the roots, the x-intercepts? So what makes quadratic equation? Sometimes, have you noticed when you're doing your homework last night? Sometimes you get how many solutions when you're solving the quadratic equation? 2. Sometimes you get none. Sometimes you get 1.
No.
Think about when that happens. What determines, therefore the name discriminant, what determines how many solutions you get when you plug in quadratic equation? Do you guys remember doing this for your homework? So anyway, go ahead. Anybody need more time to draw, by the way? Yeah? Okay, I'll give you time. And as you draw, think about that. What determines that? It determines how many solutions you get, right? So we were talking about what determines how many solutions you get when you solve a quadratic equation. So what's the equation of this? What's the solution for this quadratic formula or quadratic equation? It is x is equal to, yeah? Okay. Yeah. There you go. Is that what we got? Now, when do we get two solutions? Do you guys remember when? When you were doing your homework last time. Sometimes you got two solutions, sometimes you got one, sometimes you didn't get any. Oh, you didn't get, oh, okay. You always got two solutions? Oh, okay. But let's then think about it. If none of the homework question asks for this. But just think about what makes then. Why did you get two solutions every time? It was because, yes, Robert. Because of the plus and minus, right? Because if that number, square root, sometimes that number inside the square root came out to be a perfect square, that was kind of nice. Sometimes it didn't, doesn't matter. No matter what, you got two solutions because you have to either add that number to the numerator or subtract that number to the numerator, and then you got two solutions, right? So that's when we get two solutions. So then when do you think we'll get no solution? One person see it. When you plug this in, when do you think we'll get no solutions? A lot more people now. Who have somebody that have, yes, Caleb. When the b squared minus 4ac becomes negative. You guys remember that? When that number became negative, we knew, oh, right? This number does not exist on a number line, right? Therefore, doesn't have any solution, right? You guys remember that? So guess what that translates to? That means, yes, if you were to graph that parabola, what would that parabola look like when you have no solution? One person see it? 2, 3, yeah? Jisoo?
It'll be above or below the x-axis.
Oh, when would it be? When would the vertex be above the axis and have no solution? If it opens upward, right? When the vertex is above the x-axis and if it opens upward, yeah, no solution. Therefore, that's what this parabola will look like, right? Because this is telling you that it has no x-intercept. Does that make sense? Or if the vertex is below the x-axis and it opens downward, right? That means doesn't have any axis or root, has no root. When do you think then you get one solution? There's only one way to get one solution. Mani?
If you got 0
4?
for x in the square root.
The number in the square root, b squared minus 4ac. If that b squared minus 4ac happens to be 0, then if you add 0 plus or minus 0 to a number, you get the same number, don't you? Does that make sense? Yeah. So that means that vertex is on the x-axis. Yes?
Yeah.
So, guess what then determines how many solutions you get? B squared minus 4ac tells you how many solutions you're going to get. In other words, how many what? When we talk about these solutions, these are your x-intercepts. So if b squared minus 4ac is what? When do you get two solutions? If b squared minus 4ac is yes, positive, then you get two solutions. When do we get no solution? Yes? Well, some other yes? When the b squared minus 4ac is negative. When do we get one solution? Yes?
B squared minus 4ac is
It goes to 0. Do you guys understand? I wrote it down like this. Now when I say solution, what do I mean by solution? These are your two what? You could also write that as two roots, correct? And no real solution when, because it means no roots. When b squared minus 4ac is negative. You get one solution, in other words, you get one root. When that number is negative, okay. I mean 0. By the way, we keep referring to this number as b squared minus 4ac, b squared minus 4ac. Kind of long. So they came up with a number. They came up with a name. Guess what they call this b squared minus 4ac as? That is called the discriminant. Okay? Discriminant. Right? That determines how many roots or solutions you get. Does that make sense, guys? That is your discriminant. Does this make sense? I'll give you time to talk with your group. Okay, as you write this down, if you're done writing, ask your group. Okay, let's see if you understand this. Make sure people understand this, guys. Go ahead. Yeah, you guys are right. It should be how many roots here? 2. I wrote 1, my bad. Right, you get 2 roots or 2 solutions when that's positive. Everybody okay with this?
It's frozen.
Oh. Everybody okay with that? Any question? Yeah, so when the discriminant, right, see how it's easy? I don't have to say b squared minus 4ac. When the discriminant is positive, you get 2 solutions, which means you have how many roots? 2 roots. When the discriminant is negative, then how many roots do you get? 0. When the discriminant is equal to 0, then you only get 1. And that happens to be your vertex, isn't that right? Yes? Yeah.
What happens if A equals 0?
Well, if A is 0, then you don't have a parabola. You have a line, right? So you don't have, right? You wouldn't, if you're talking about a parabola, if A is 0, then we're not talking about parabolas anymore. We're talking about a line, okay? Good. Any other question? All right, then let's go back to that pictures that we drew with all the vertex and so forth. And we could now add something to that. Let's see if you could understand now what I mean. Didn't we draw all this picture? So, right, when so we can now write something underneath. When do we get two solutions like this? Underneath we could write when the discriminant is positive. What about for no solution? When the discriminant is negative. What about one solution? When the discriminant is 0. So I wrote it down right here, you see? So you might want to write that down. Instead of saying positive, I said greater than 0, right? Instead of saying negative, I wrote down less than 0, and then, of course, equal to 0. So we could now be a little bit more specific, right? When does this happen? Well, you could just look at the discriminant, and you could tell. Okay. So on your homework tonight, it's going to ask you, without graphing, can you tell where the vertex is? Is it going to be above the x-axis or below the x-axis? You see what I mean? So you kind of have to look at this picture, or remember this picture. It should make sense, right? If you figure out that the discriminant is positive, and if A is what? Depending on whether A is positive or negative, you will see whether or not the vertex will be above the x-axis or below. Question?
On the homework, if it just asks to say if it's above or below or where it is, do we have to solve the whole equation and get like coordinates, or can we just go to see if b squared minus 4ac is constant?
That's a very good question. Okay, so here's here's what she's saying. If your homework asks, and this is all it asks, like whether or not the vertex is above or below the x-axis, what she's saying is, do you have to plug into the whole quadratic equation? No. All you have to get is just the discriminant, right? They're not asking exact x coordinate of the x intercepts. Does that make sense, guys? So if that's all they're asking, yeah, you don't need to plug into the whole quadratic equation. You just need to look at the discriminant, right? But if they're asking for the x-intercept or roots, then yeah, you need to plug it in. Exactly. Yeah, question?
So basically tonight we're just using the discriminant?
Yes. So sometimes they ask you for the root. Sometimes they ask whether or not the vertex is above or below the x-axis. The problem. So actually, let's do some examples. Okay. Any? Are we okay with this? Does this make sense? Do you see why I have the discriminant negative, positive? Okay, equals 0. Okay. All right. Let's move on. So let's do an actual homework problem. So this is what they're gonna say. They're gonna say find the value of the discriminant. Do we know how to do that?
Yeah.
Yeah. What is the discriminant? B squared minus 4ac. Don't put the square root on it. Okay, you don't need the square root. Okay, just the number inside. Okay, the number inside the square root. And then tell how many real number roots. What are roots again? X-intercept. How many real number roots the equation has? And guess what they're gonna ask? The third thing they're gonna ask whether or not. Yeah, what's above or below? No, not the parabola. Whether or not tell whether or not its vertex is above, below, or on, right? There are three possibilities, right? Or the x-axis. So let's do an example. Okay, so here. I should have actually, no, this is a little bit, it should be equals to, not 0, but it should equal to y. So they're nice. So let me actually change that. Okay. Here you go. So I changed it to y. Now, of course, when you are looking for then discriminant, okay, do you think you need A, B, or C? What's your A for this one? 4. What's your B? 4. What's your C? 1. Okay, good. Go ahead, everybody. Tell me what the discriminant is and so forth, and see whether it's above, below, or okay, on. Go ahead. Okay, so did you all get the when you plug in? By the way, when you plug in, did you use parentheses?
Yeah.
Okay. Did you? No, you should have. Okay, then did you all get 0 for this one?
Yeah.
Yeah. Okay. What does that mean? How many roots does it have?
one.
It has one root, so we were able to figure out answer first question. It says how many roots does it have? It has one. Is it above or below the? Is the vertex below, above, or on? This one's easy. It's going to be on. Okay, so by the way, when you have one root, it's called double root.
What?
Yeah. Anyway, we'll talk about that later. It's called double. Try this one now, quickly. So A is what now? 2. B is? What's B? -3. What's your C? 5. Because of time, let me just do this to show you. Okay. When you plug it in, you get negative. Guess what? No real root. Okay. When you get negative. Okay. Now, is this going to be above or below the vertex? What would be the important thing to look at? If I know that discriminant is negative, okay, what's going to tell us whether or not it's above or below? Yeah, Ben? If A is negative or positive, correct? So if it has no root, and look at my A. A is what? Is it positive or negative? My A. My A is positive. That means it opens upward or downward. So it's going to look something like this, right? It's going to have a vertex above. It's going to have no vertex. If it opens upward, guess what? Doesn't it have to look something like this? Can the vertex be below here, below the x-axis? Then you would have how many roots? 2. Guess what? So how many? Where is my vertex? Above. Is this easy or hard? Yes, close here. Right? Since my A is positive and it has no roots, vertex must be what?
Question.
Yeah, above.
If A is positive, it's
Uh-huh.
like a happy day, so you're smiling, so the smiley face goes up, and if it's negative, then it's like a bad day.
Yeah, you can think of it that way. If you like. Yeah. A is positive, happy. Okay, smiley face. Does this make sense?
Yes.
Okay. Again, let me ask you this. One root is called double root. We'll explain why in a minute. I mean, next time. But it's when they refer to double root, it means one root. It sounds like 2 roots, doesn't it? Double. But the reason why it's called double is because it's 2 of the same one. That's why it's only one root. Does that make sense? So don't think of double root. It does not equal to what? 2 roots. Okay. Double root is how many again? 1. Okay. Your homework, I'll give it to you in a minute. Okay. Good. It's 1. So what I did for you guys is I graphed for you y equals to ax squared plus bx plus c. No, look what happens if I change the value of a. If a is positive, you know how c opens upward? And if a is negative, guess what happens? Opens downward. And look what happens as a gets bigger and bigger. It gets narrower, doesn't it? If a gets more negative, of course it opens downward, but as it becomes, absolute value of a becomes bigger and bigger, it gets narrower, doesn't it? Yeah, question?
Does it become straight?
Actually, yeah, it does. It will never become a line, but it gets narrower and narrower. So, okay, good question. Then, look what happens if I change the value of, let's change the value of c first. Anybody know what the value of c is? By the way, look what happens when a is 0. You get a line. See what I mean? Anyway, okay, so you don't want a to be in. Okay, what happens if I've changed the value of c? It just moves it up and down, that's all. Guess what the c is? Look at c. If c is 1, it goes up at 1. C is the y-intercept for the parabola. It's kind of cool, right? Now, what happens if I change the b? Well, you have to have the same y-intercept, don't you? So when you change the b, and you have to have the same steepness, so all it does is it makes a side to side, but it keeps the same what?
Oh, that's projected.
It has to have the same what? Y-intercept. Y-intercept cannot change. So it goes left to right, but it does that. Okay? Yeah?
Can you change A, B, and C like that, like all at the same time?
Yeah, but we don't need to do that right. Okay, so what I want you to really show you, watch this. Yeah, we'll do that later if I have time. But what I want you to show is, we know the actual order pairs for the x-intercepts, don't we? It was what? Negative b plus or minus square root of b squared minus 4ac all over 2a comma 0. So what I did was I actually plot that point here using a, b, c, d. Those are my 2 roots, right? And look what happens as I change the value of a. Guess what it's going to do? Because I put them into a general form, it's going to always give me the correct x-intercept. Look, if I change it, I can actually make it move automatic. Oh, let me slow it down.
It's so weird.
Okay. And then let's what happens if it changes value of c. You see how my roots, right? It's always correct in this correct place. I know the actual order pairs, the exact order pairs. Does that make sense? Okay, so do you guys understand what I'm trying to say here? Okay. Now, let me show you a double root. Which means you can kind of imagine. See, look, you see how the roots kind of gets closer and closer together, and guess what? Those two of them becomes one. That's why it's called double root. Because when you have one root, because they're the two of the same one, and we could actually show this algebraically why this is true. Does that make sense? Any question? Do you understand? Okay. All right, good.